Now that we are familiar with interfaces, abstract classes, and Java's inheritance ideas, we will discuss lists and collections in a more general term. We can think of a collection in items of various terms depending on how we organize their storage. We have only used two types mentioned here, strings as collections of characters, and lists that are array lists or arrays. We have mostly discussed the idea of a collection of a single data type. Strings are really just arrays of characters. We have stated that arrays and array lists contain a single data type only, but then we refine that to create arrays and array lists of interface or abstract class references that can manifest as different concrete objects of a derived class. So we have kind of talked about homogeneous collections, an array or an array list that can only contain one kind of reference. But it's also kind of heterogeneous as well because it can contain objects of derived classes. The four main categories of collections, of which we will only study one really, are the linear collections, hierarchical, graphical, and unordered. And the book has really nice images for those. A linear collection, like our arrays and array lists, are like people in a line, ordered by position, and their placement relative to another item is fixed. You might think that we've already covered hierarchical collections, but what we've done is we've talked about hierarchical organization of objects. A hierarchical collection uses a lot of the same words as far as parent and child relationship, but these are things like binary trees, tertiary trees, and it is, instead of a list, a way that you would store one object relative to another. And you would look at it like this. This would be the parent node, you would call it, and here would be a child or a leaf, and here would be a leaf. And once again, this does not have a linear representation. You have objects in a position relative to another object. Something like electrical circuitry or airplane connect could be represented as a graph. And some objects are connected to other objects, but not all are connected in the same way. It's not hierarchical, it's not linear. And then you have your good old bag. They're just thrown in a bag and they have no order, but there are a certain quantity. You can check to see if a certain object is in there. You can check to see if one has been removed, check the size and all that stuff. I think you read through this. So these are kind of important. So if you think about collections and you think about what you want to do with a collection, lots of stuff is very logical. Do you want to see if something's in it and grab it? Do you want to remove it, insert it? If something's there, do you want to replace it? Okay, so all of these things that we have kind of talked about in arrays and array lists, you could do in a general collection. You have to be careful with casting in collections if you have methods that are specific to derived classes, like we've talked about before. And I'm not going to talk too much about this slide because this is no different really than an array list. It's in this particular lecture because you could think of this in the much more general term as just any old collection. Adding, removing, setting. I'll talk about this a little bit more in the code that we're going to talk about, and specifically I'm going to talk about shape, but this is a list of shape references. But the array list is what implements the list. Do you want to look at your objects based on their index? Maybe something keeping it in order? Do you want to see if something is there, a content-based operation? Or do you want to have a comparison between one object and another object based on its position? Yeah, not much to say about this one or this one. So these are the same kind of ideas that we've talked about before with array lists. I'm going to pull up the actual reference sheet for the list interface, and from now on you're going to use that on all your tests and quizzes. It's the same one that you'll be using in May on the AP test. And another look at the methods. From now on, when you get a reference for a quiz or a test, you're going to get the same one that you're going to get on the AP exam. And how that applies to us is right down at the bottom. Well, let me look at the top. So at the top, you'll see that it has the objects and other stuff right there. Has the integers, doubles. I'm having trouble. And it'll give you some information about the math library, but right now I want to focus on the list and how they are giving you the information. You'll see at the bottom right here that they talk about the array list, which is a class, and tell you that it implements the list interface. Okay, how do you know list is an interface? You see it right here. And the methods that you will be responsible for are the ones that are listed here: size, add, edit, index, get, set, and remove. This E right here is the object that you are filling it with. So it's just meant as a stand-in, like shape, like person, like object. Okay, and so that's just the data type. That's how they notate it. All of these on the right, the descriptions of the methods that you already are familiar with from array list, tell you what's going on. They're no different than the array list, but what you have to know is that an array list implements list. It means that it implements those methods, right, that are defined in any interface, and these are the ones that you're going to be responsible for. I want to show you an example of using the list, and this is going to seem like it's just like we did already with the shape and when I talked about an array list of shapes. The key things are right here. I'm going to declare this as a list of shapes, which is the interface, right? And how am I going to make a new list? I'm going to implement it with an array list. So just like before, you couldn't make an object that was an interface or an abstract class. I have to take this list reference, list 1, and give it to an object that you can instantiate. So that just kind of adds one layer of trickiness, I guess. The rest of the stuff is just like regular. So since this is an array list of shapes, then you have to make a new shape because we're using the same interface as we did before for shape. And so I'm just choosing circle. Okay, so I'm to list 1, which is a list reference. I'm adding a new circle to the array list and then asking it to draw. I'm going to go ahead and run it. And it comes up. I'll put it on fast. We can watch the circles draw. And so really it's no different than we did before. The key things being that we want to have a generic collection. What is that collection? It's a list.